Hi, in this video I'm going to make a 3D scan of this shuttle. It's a synthetic shuttle from Yonex, and then I will make a 3D scan, reverse this in CAD, and then I will try to make a 3D print and see if this 3D print shuttle will actually work. I made several versions of this shuttle and see if any of these will work. This is an experiment to see if the 3D scan to printing will work with this shuttle. Okay, before we start scanning, a shuttle usually weighs around 5 grams. So if I put it on a scale, it weighs around 5 grams. The feeder will weigh around 2 grams. That's very light, and this part is made from nylon and it's very thin. I measure only 0.3 millimeter thick, and if you look closely you see that it has 16 of this, the same as a real feeder shuttle. It has different perforation. This side has smaller holes and this side has a larger hole. The reason they do this is to make a shuttle spin, so when it's run through the air, so this side will have a higher pressure, so it will push the shuttle to spin in this direction. So when it spins, it generates a gyro effect, so it will stable when it's travel in the air. And one more thing, if you look here at the curve, you see this curve is asymmetrical. This profile will help to create a spinning effect when the shuttle is traveling through the air. This one is longer than this side. The longer side also has a denser mesh here. So when it's travel, if you push the shuttle in this direction and it will spin like this. To replicate the shuttle perfectly, I need to make this shuttle spin. It also need to have the same weight ratio between the head, which is made from cork, and the nylon part. The nylon is 2 grams and the cork is 3 grams. So I need to design each part separately so that I can control the weight of each part. The cork part and the feeder is joined by using a thread. So I make a male and female thread. This way it will be easier for me to experiment with the different weight on the cork, and it will be easier to print. So I can print the feeder in this direction and also I print the cork in this direction. I still can have a round shape like this. I'll use Creality Scan Raptor X for making this 3D scan. I make a 3D scan into orientation, this direction and this direction, and then I will merge it with the Creality Scan software. And there's no place that I can put the 3mm marker on because it's very small. So I will use geometry for referencing when I merge this one. I will lace it up like this, so it will be easier for me to erase the turntable after the scan. Creality Scan has a new update. It doesn't say anything about what's the new feature. Let's see what's new in this update. Okay, it's 3.3.40. Okay, use 0.15 for the resolution. Click on scan. I use 7 lines to make this 3D scan because it's very small. So you can use either original Raptor Pro. It will get you the same result. I think the exposure is alright, but I may need to adjust the brightness of the infrared. Exposure of the laser is alright because I can see it in the preview window. I won't be using the global marker because it's small. make a new scan, same resolution 0.15. Start the scan. I'm not going to scan inside of the feeder because it's very thin, 0.3 millimeters. Okay, let's process the point cloud. I only need the outside of the feeder, so I will trim this. It's the first scan. 0.15. As you can see, you won't be able to see the mesh perforation. Okay, merge the scan. I don't think auto merging will work, but I can try. No, it's not working. So I need to use manual merging. I didn't put the marker on because there is no space to put the marker. So I will look for some marking on the cork. See here, it has 3 lines here, and this one has 3 lines. So I use this as a reference. 1, 1, and I'm gonna choose this point from the lead line. 2, 2. It doesn't have to be like pixel perfect location. It only needs an approximate value. So I'm gonna count 1, 2, 3, and 4. I'm gonna put it here. Do the same here. 1, 1, 2, 3, and 4. Right? You only need 3 points. Click on start. Right? So now it's merged. Click yes. Exit merging. Okay, because I'm gonna use this for reversing in CAD, and my CAD Autodesk Inventor use point cloud for reversing. So I will export this one as an ASC format. Okay, let's take a look at the 3D scan result in a render scene. This is from Raptor X. Perforation of the mesh is not present in the scan because the mesh is too dense. So if you need to see the mesh, you're gonna need another scanner. Scan this one with MAF3. You can see that it can scan the perforation of the mesh and the detail of the cork. And as you can see that the definition of the scan is higher than the Raptor X 7-line laser. So on the right is MAF3. On the left is the Raptor X 7 lines. Okay, let's start reversing. here's the printing result. The feeder weighs 5 grams. The original feeder weighs only 2 grams, so it's about 2.5 times heavier. This is the lightest version that I can do. The wall thickness is only 0.8 millimeter, so it's only 2 layers of the wall. I don't think that I can make it lighter than this. And if I add more perforation, it's supposed to have 16 of this, but this one has only 8 perforation. If I use 16, it will be too small and it will break. It probably won't work because this feeder part is too heavy. So okay, next the cork. For the cork, I made a several version. I add solid filament inside to increase the weight because I think that if this feeder is too heavy, then if I add the weight to the cork, it can increase the balance. It will nose down. So let's weigh the cork, 3 grams. So the cork has the same weight as the original cork, but the feeder is too heavy. And this is a historical print. You see this the layer shift here. There was an earthquake in Bangkok while I was printing this. I think the magnitude is 5.5 to 6 magnitude. My house didn't lose the power, so the printer continued to print until it's finished. But the time that the earthquake started, it gave this layer shifting. This layer shifting was caused by earthquake while I was printing in a K1 Max. So I'm gonna keep this one because it reminds me there was an earthquake in Bangkok, and I hope for the best for the survivor that's trapped inside the building. The rescue operation is still going on. I also made other different version. This one, it has 16 feeder because in the standard shuttle it need to have 16 feeder, so I give it 16. And I tried to make it spin as much as possible. So I designed a blade like this, and to make it spin, and I put some stiffener in the center of the blade here to keep the stability. The blade is only 0.8 millimeters thickness, but the weight is 8 grams. So it's heavier than this one, the earthquake version. So I don't know if this will work. I think if it spin when it's travel in the air, it will give the stability to the shuttle. And I also make this version which is has a narrower stem, but it has only 12 blades. See if this will work. Okay, let's test it. But I won't use this one. This is a historical print, earthquake version. So I will test with a regular shuttle first. When I hit it, it's supposed to spin. It spins, but it doesn't spin that much. Okay, I start with the clone one. This one is 3 grams cork and 5 grams feeder. I don't think it will work. It doesn't work. It's not spinning and it's not balanced. So the feeder part is too heavy, as you can see. It's not working at all. So I break it. So here it's too thin and I break it. So let's try with another one. This one supposed to spin. I hope it will. Okay, let's try. It's not spin and it's break. It's break on impact. So the blade is too thin and the stiffener is also not enough. I'll try again with so it's shattered into small pieces. Okay, this doesn't work. Let's try the last one. This one has 2 stiffener rings and the blade is smaller. I think this one is 12 feeder. It survived the impact. My kid doesn't know how to play badminton. Start to break here. It's already start to break. Maybe you can try one more time. Okay, it separates itself already, so it won't last the impact. Okay, after testing, none of this is actually work. The feeder is too heavy. It's not spinning because there is no perforation on the feeder that keep the pressure difference and spin. So this one doesn't work. It's too thin, too brittle, and most important, it's 2.5 times more heavy than this one, so it doesn't work. This version also too heavy, not working, and it's too brittle. This version is a little bit bare, but it's still too heavy. This one is the feeder weight alone. The feeder weight is 7 grams. This one is 9 grams for the feeders. So none of this is working until we have a better printing technology and the materials that can print thin and perforate and light a part like this. So at least I learned something today. Okay, thanks you guys for watching. I'll see you in the next video.